For number 5, it says graph the equation in standard form. I'm going to use the cover-up method. So I'd cover up the y, and I would say 9x equals 18. Divide by 9, and x is 2. So I put a 2 on the x-axis. Then for the y, I cover up the x, and then 18 divided by 3 would be 6, so on the y I put a point at 6. Then I connect those two dots, or 2 points, and then that's it for that one. In number 6, we have an inequality, which is in slope-intercept form. So I'm going to start with the 4 on the y-axis, and then my slope is going up 1, right 1, and then I also can go down 1, left 1. I see that my inequality is less than or equal to, which is a solid, and less than means shade down. So I draw a solid line, and I have to shade down, which is less or under, so I would shade this part of the graph. Okay, in number 7, we have 2 points given to us, so we're going to label that x1 and y1, x2 and y2. To plug these points into point slope form, we need a slope. So to do that, we need to plug in the points to this formula, which is given to you on the front page of your test. So I would say y2 is 3 minus 1, and then x2 is negative 13, and x1 is negative 12, making that a positive. So 3 minus 1 is 2, and then that would give me negative 1. So my slope is negative 2. Once I have my slope and my point, I can plug in those numbers to this part of the equation. So y minus 1, the slope is negative 2, and then x minus x1, which is a negative 12. Knowing that two negatives make a positive, I've got y minus 1 equals negative 2x, and then negative 2 times 12 is negative 24. Then I add 1, and we get y equals negative 2x minus 23. For number 8, we're going to distribute the 6 to the 3 and the negative 2. And we see that we have a negative exponent here. So I make this a fraction, and I move the negative exponent to the bottom. So x to the 18th would stay at the top, and y to the positive 12th would move to the bottom. In number 9, we're subtracting the exponents if they have the same base. So for the x, 7 minus 2 would be 5. For the y's, 10 minus 4 would be 6. And then for the z, 8 ninths minus 2 ninths would be 6 ninths. But this can reduce by 3. So I would rewrite that as x to the 5th, y to the 6th, and if I divide this by 3, this would give me z to the 2nd over 3, so 2/3. Okay, and then for number 10, I use the numbers negative 1, 0, 1, because they're in the middle of the graph, and I plug them into the equation. So 5 times 2 to the negative 1, we apply our exponent rules, so I need to move that to the bottom of the fraction. 2 to the first is just 2. 5 divided by 2 is 2.5. Then I plug in the 0, so 5 times 2 to the 0. 2 to the 0 is 1, and 5 times 1 is 5. Then for the 1, 5 times 2 to the first, 2 to the first is 2, and 5 times 2 is 10. So at negative 1, I go up 2.5. At 0, up 5. And for 1, 10 over 1, up 10. Again, you draw a curve that gets really close to x, but never actually touches the x-axis.